Hello, this is Mrs. Scarpel, and in this video I'm going to go over how you find the average rate of change of a function over the interval a to b. So you're going to need to find the change in y values, or the change in values of your function. You're going to want to take the second value and subtract the first value. That's going to be a change in y values. To find the length of the interval, you take the second value of the interval and subtract the first value of the interval. That's going to give you your change in x values. What this means is you're going to find the value of the function at the beginning of the interval and at the end of the interval, and then you're going to divide by the length of the interval. If you're looking at graphs, specifically with the graphs of exponentials, you may see that lines are drawn to indicate the interval. Those lines are connecting 2 points on a curve, and we call those lines secant lines. So what do I mean by all of this information? So here we're given the exponential function 3 times 4 to the x. And we need to find the average rate of change for the following intervals. That means I need to find the value of f of 3, subtract the value of f of 0, and divide it by 3 subtract 0. So the value of f of 3 is found by taking 3 times 4 to the third. And we're going to subtract 3 times 4 to the 0 power. And that is all over 3 subtract 0. So 3 times 4 to the third power is 192. 3 times 4 to the 0 power is 3, and we're going to divide this by 3. So 192 minus 3 is 189, and we're going to divide that by 3. So 189 divided by 3 is 63. So we have an average rate of change of 63. Same function, different interval, so we're going from 2 to 4. We want to find the value of f of 4, subtract the value of f of 2, and divide by 4 subtract 2. So f of 4 is going to be 3 times 4 to the fourth. F of 2 is going to be 3 times 4 squared, and we will divide that by 2. So 3 times 4 to the fourth is 768. We're going to subtract 3 times 4 squared is 48, and we're going to divide this by 2. So 768 minus 48 is 720, divided by 2 is an average rate of change of 360. Now, you might be wondering, since it's the same function, why isn't the average rate of change the same? This isn't a linear function. If it were a linear function, the average rate of change would be the same. We call that the slope. But because this is exponential, you have to keep in mind that with an exponential function such as this, we're going to have a graph that looks like this, that is going to grow, and as the x values get bigger, the rate of change increases. So we had an interval of 0 to 3 with a much smaller rate of change as we did the interval from 2 to 4. That means our graph is steeper in the interval from 2 to 4 than it is in the interval from 0 to 3. And this is how you find the average rate of change for functions. This process will work no matter what function you are working with.